and without regarding this term personalized medicine. So if you could kind of talk to us about what that exactly means to you and speak to our young entrepreneurs and future leaders looking to develop supportive services for the medical community in this regard, what necessities or opportunities do you believe may help this concept to develop and gain greater traction?
It's a great question. I mean, the word personalized medicine has taken off in multiple directions and means many things to many people. You know, if I treat you based on your ethnicity, presumably that's personalized medicine too. But what it really means is what we call precision medicine, which is the next step. And precision medicine is looking at your makeup by the technologies that we have to try to get a better treatment tailored to you. Historically, it's been somewhat reductionist, right? We use what technologies we have, like sequencing your DNA. So sequencing the DNA is cheap. In 1975, in the Monsanto annual report, it was $150 million to sequence one gene. Well, today it costs pennies to sequence a gene. So it's a scalable, cheap technology where we can learn something about you as an individual. But it is one small piece to the puzzle. You know, a really important point I want to bring out is something called coarse graining, which is a concept from physics or photography, where you take the lens of a camera and you make it really, really blurry, and you just see the outline of a human. Well, that's a human, and then you can get finer and finer grain and see all the details. Well, the idea is that we can correlate an element, a coarse-grained element, to biology and personalized medicine. The climate modelers do it by looking at the shape of the cloud, and they don't have to go up 20,000 feet and measure the wind speed, the temperature. They just look at the shape of the cloud. And so just measuring, for example, how much I move during the day with a device, that's a coarse-grained element. And that may be just as important as my DNA in correlating to health or a particular outcome about health. And so what we challenge the entrepreneurs is think differently. Don't think like everybody else and jump on the bandwagon. Everybody's sequencing DNA today. Think differently. It may be that measuring, for example, heart rate variability is more important than sequencing your DNA. You know, when you're relaxed, your heart rate is exactly even. Bang, bang, bang. When you're a little bit stressed, it's off by 1 or 2 milliseconds. When you're very stressed, it's off by a lot more. And so there are devices now that can look, it's green when you're relaxed, yellow when you're a little stressed, red when you're very stressed. You know, it's like a mood ring of the old days, but it's got real science behind it. And that coarse-grained element can be more important than measuring all your blood factors or you're looking at your DNA. So we challenge you to be different and measure a different aspect of each of us so that we can actually make healthcare better.
Wow.
Fantastic.
Great. Well, I want to say thank you again for joining us and taking the time to meet with us today.
Sure.
And I read your book, End of Illness. I've seen your Charlie Rose interviews, and I really like the message that you're getting across about, you know, taking a look at the whole picture of treating a patient. And you know, there's a couple things you mentioned in your book that I was hoping I could get you to maybe expand a little bit on for me.
Sure.
One of them was talking about, you know, research groups and citizen scientists, peer-to-peer reviews. And my question is, do you think that we'll be getting to a point where patients will be empowered and engaged to kind of give some feedback and join in and discuss some of these, some of the research and be a part of that?
We better. You know, listen, I mean, the future of treating disease, of curing disease is going to be with all of us. It's going to change from the bottom up, not the top down. And so historically, it's we docs who made the decisions and made the field change. And obviously, we didn't do that good of a job. And so whether it be the citizen scientists, it be the patient group, or the family members of a patient, we have to start to do things differently. And it requires a couple of substrate changes first. Right? One is we need to deal with privacy. So we need to figure out a way so that the privacy laws don't really block all of us. If I told you log into Wells Fargo and pay a bill, you wouldn't think twice. If I told you go to your doctor's office, take your healthcare information and send it to somebody else, people cry foul. We need to figure out a better way so that we can all understand what are the risks, the benefits of sharing data. And that really goes to the key component that's missing now, which is standardized data elements. We can all share and learn together if we all use the same language, but historically we haven't in our field. You call it a broken leg and you call it a fractured leg. So no matter how much hard work you do, the databases don't talk and they don't interact. We need to agree on one of the common data elements, a common language for all of us to use. Right now there's 6 dominant ones in the country. Somebody has to take a stand and say, listen, everything going forward is going to be with one set of elements. And then we could all share, we could all interact into how we do it. There needs to be transparency with who we are and what we are. You know, one of the biggest problems we face now with sharing healthcare information is it gets corrupted because somebody comes in and acts like they're a patient with a disease or part of a group, and in actuality they're a salesperson trying to sell something. And if they take the face of a patient, I had this drug and it changed my life, then they're likely to get hundreds of supporters in buying the drug. Well, that's not what this information needs to be used for. So there needs to be a way to verify, identify, use common data elements, and all of us start to speak the same language with real privacy, and we're going to make a difference. You know, one of the ways other fields have done it is to have a broker in the middle so that there's somebody there who verifies identities and at the same time is able to ensure privacy by sometimes taking off identifiers like names and things about you so your information can be used by the researchers or other citizen scientists to make progress in a disease. Every patient I have, if I say, listen, do you want your information to be part of the cure for your children and the grandchildren, I have never had somebody say no.
Yes, thank you. I totally agree with you. The de-identified patient data, the more people that are willing to share that, the bigger changes that we could make. And I think that once we have that system in place, we're really going to see the transition for patient engagement. So, and some of the other questions I had for you is nutrition and preventative care. So maybe we can touch on a bit on how the environment and nutrition plays a role in preventive health and what we can do to kind of improve that.
So, big topic, but real and important. You know, we did a story with Charlie Rose, not yesterday, but the day before, where there was really great data coming out of 2 major centers, out of Harvard and out of London, showing that the closer you lived near the airport, the higher your risk was of heart disease. And this was really well controlled for socioeconomic factors and very well done. And so the stress of hearing the planes land all the time raised blood pressure, it raised heart disease, and in the British study actually raised death rates. And so when you go to your doctor, right now it's what's your cholesterol, what's your weight. In the future, the doctor is going to say, or they should today, start to say, where do you live? What's your environment? Is there stress there? Just like they need to ask you, what do you eat? What's your meal schedule? What supplements do you take? All of those go into risk, whether it be elevating risk or lowered risk. You know, a cholesterol value is a relative risk value. If your cholesterol value is up, doesn't mean you're going to get heart disease. It means you're a higher likelihood than average. If it's down, it doesn't mean you're not going to get heart disease. It means you're slightly lower risk than average. And so all of these factors build in. And so in the end, that's what's going to be true personalized medicine, is we can take into account your environment, your diet, the things you do during the day, as well as your genetics and your lab value. You know, most of the common diseases, heart disease, cancer, Alzheimer's, they're only 50% genetic, but they're 50% environment. You could blame your parents for half, but the other half you're in control of.
So basically, medicine is going to be our ability to manage better our lifestyle.
No question. And then to do it in a fashion that regards data. Every time there's a very well done study that really has been replicated and really makes sense, we have to say this is validated science. We have to raise it to a pedal, and then we need to act on it. And so what we're doing now, unfortunately, through the media is we're treating everything the same. A poor study and a great study we're treating the same with the same kind of press release. And at some point, we all have a right to do whatever we want. We can smoke, we can drink soda, we can sit on the couch all day, but at some point we have to do the right thing. And we have to say, when scientific data hit a critical mass, we need to act on it. And we need to create movements to act on it. In order to change healthcare, it's what's necessary. Healthcare in the United States is 18.5% of gross domestic product, and it's growing. It is one of the biggest problems we have. And the action we take is all around healthcare finance. we need to start to take action around healthcare, and that hasn't happened yet.
Well, thank you so much for sharing all this insight with us, and I hope they will be really helpful for the participants of the hackathon over the coming months. So our project is called Hack for Big Choices because we want to help and encourage talented people all around the world to use their talents and make a big choices, either in healthcare, education, or design and technology.
Mm-hmm.
So I would like to ask you, what has been your biggest choice that had required to use your talent and your knowledge?
What do you mean my biggest choice?
Your biggest, when you were in front, as being hard for you to make that choice, so you know how important it was.
You know, I've been a cancer researcher and doctor for many years, and historically a doctor is in one domain. I'm in the lab, and I've got about 40 people in my laboratory developing new drugs and new technologies, and I treat patients. And so the choice to actually start to be a spokesperson, to work with the media, was a very different thing for somebody in my situation to do, and it was very, scary. Many researchers and doctors push you aside when you start to work with the media. But it really is my obligation to educate. I started to look and say, I can make big changes in the laboratory, develop new drugs and treatments, and that's great. But at the same time, if I don't push on the things we know, whether it be changing behavior, understanding, and really a comprehension of science, then I haven't done the full impact that I need to. And so I made the decision to actually work with the media, to do CBS News twice a week or once a week, some weeks, with Charlie Rose and the team at CBS This Morning to try to make a difference. And a lot of people look down on it, but to me it's my obligation. I have to push, and this is a way we can make a big impact on society.
Thank you. This is a great message. So we have few minutes left. Brandy and Ramon, do you have anything else you would like to ask to Dr. David Egus?
Yeah, I have a real quick question. One of the primary topics that we're looking to address in terms of the hackathon that we're putting forward is the idea of confronting depression and helping to bring mental health issues more out of the shadows and into the forefront, as far as ideas that young people can think about it in terms of developing ideas in the medical sphere. Can you speak a little bit about sort of the effects that depression that you see on your particular patient population that aren't necessarily often associated with traditional depression?
So there are two aspects on depression. One is, you're right, it is an enormous drain on society and on the individual and on their family. And it's a topic that we need to bring out into the open. And so we can talk about it all we want, but it's not going to make as much of an impact as if we develop a technology to assess it. Mm. So the hardest part about depression is that it's a moment in time when I talk to a patient. So I say, how are you feeling? I'm feeling all right today, even though the last 29 days they were depressed and not contributing like they could to their family and society. So if we had, first of all, long-term metrics for it and technology actually used to quantitate it, we would be able to improve the field better and get better ways to treat it, to prevent it, and to deal with it. Depression right now is a very qualitative thing. You ask a couple of questions and you get answers back. When you're depressed, your whole body feels differently. So there should be ways we can measure that, both in the short run and the long run. The diabetes world changed when we were able to develop a blood test that gave a 90-day average of the sugar. Right, because everybody, the day before they go to the doctor, they eat the right thing, they do the right thing, and their blood test looks great. But by that 90-day average, we transformed how we deal with people with diabetes. Well, wouldn't it be neat if we had the same thing to measure mental health? And I think technology is really going to allow us to be quantitative, to develop drugs better, use them in the right person, use behavior modification better, and develop ways to actually change the way we think and behave. And so we haven't focused on that historically. If you look at the percentage of the NIH budget and research budget in the country that goes for technologies themselves, it is a tiny, tiny fraction. If you look at the budget that goes for technologies associated with the brain, it's an even smaller fraction. So that's where I would put the emphasis.
Well, again, thank you so much, and I think that all these insights will help all our hackers to come out with a new solution, at least start to think in this